Hey everyone, and welcome to The Explainer. You ever have one of those brilliant ideas, for an app or a website or just some little thing that would make life so much easier? And for most of us, that's kind of where the dream dies, right? Because the gap between that amazing idea in your head and the rigid, complex language a computer needs, well, it's huge. But that barrier, it might just be starting to crumble.
Really think about that for a second. What if programming wasn't about hunting for a missing semicolon or memorizing weird syntax? What if it was just a conversation where you could just describe what you want and the code, it just shows up working perfectly? Yeah, it sounds like something out of a movie, but today we're going to dig into a new way of thinking that's trying to make that exact thing a reality.
And this, right here, this is the problem in a nutshell. On the left, that's how we think. It's a simple request driven by what we want. On the right, that's what the computer needs. It's complicated, it's picky, and it has absolutely zero patience for mistakes. For decades, bridging this canyon has been the single hardest part of programming. We think in terms of what we want, but we've always been forced to code the how. So, to really get our heads around how we can build a bridge over that canyon, here's our game plan. We're going to walk through 5 key parts in this explainer. We'll start with the problem itself, then look at how you design a new language for AI, see how it actually works, figure out how we can possibly trust it, and then finally dream a little about what it all means for the future.
Okay, first up, let's just double-click on that core problem, ambiguity versus precision. The way we talk is kind of messy, right? It's filled with shortcuts and shared context. We can say, hand me that thing, and the other person just knows. But a computer, it hears that thing and just freezes. It needs absolute total precision. And that fundamental mismatch is the nut we're trying to crack.
So, if our natural language is the problem, what's the solution? Well, it's not just about trying to make AI a slightly better translator of our messy thoughts. The idea here is much bigger. It's about designing a whole new language from scratch, a language that's purpose-built to be a bridge, a middle ground where an AI can meet us, truly understand our intent, and turn it into perfect code.
And the philosophy behind it all is right here. Minimizing the cognitive load. That's really just a fancy way of saying making it easier to think. The whole goal is to shrink that gap between having an idea and seeing it come to life, to make that journey from your brain to a working program feel almost effortless.
So, how do you actually do that? Well, it's built on 4 big ideas. First, the code should feel like English, not like some alien script. Second, it's got to be contextually aware. It needs to be smart enough to remember what you were just talking about. Third, you tell it what you want, not how to do it. So you say, find these users, not run this loop, check this field, you get the idea. And finally, making it easy to read is way more important than making it short. A human should be able to glance at it and get it, instantly.
All right, so principles are great, but let's get into the nitty-gritty. How does this actually work in the real world? How do we go from just saying something to having a machine take real, concrete action?
And this is where you can really see the magic. Look at the human request. Now look at the AI language version. They're almost the same thing. It's designed to understand those simple, natural connecting words we use all the time. Words like if and then, and map them directly to programming logic. It's code that literally reads like a sentence.
But it gets even smarter than that. The language is built to handle our ambiguity by understanding context. So if you write one instruction, and in the very next line you refer to it, the system is smart enough to know you're talking about the result of the last thing you did. This one simple feature, it just wipes out an entire class of really common, really frustrating bugs. It feels less like coding and more like a real conversation.
Okay, so the AI can understand us. That's huge. But it immediately brings up an even bigger question. Can we trust it? If an AI is writing our code, we have to be absolutely 100% certain that code is correct, that it's safe, and that it's secure. This next part is all about building that trust, because trust isn't something you can just hope for. You have to engineer it from the very beginning. And here, it rests on 4 critical pillars. First, correctness, making sure that code doesn't have simple, avoidable mistakes. Second, safety, making sure the code can't accidentally wreck your system. Third, security, protecting it from the attackers. And finally, and this one is so important, explainability, the ability to ask the AI, hey, why did you write that code? And get a clear, honest answer.
Let's just zoom in on one of those for a second. Safety, and specifically, sandboxing. The best way to think about a sandbox is like a secure, padded room. The code can go in there and do its job, but it has very limited tools, and it can't break through the walls to mess with anything else in the larger system. It's an absolutely critical way to prevent unintended damage.
So when you put all of these pieces together, a really clear strategy emerges. You have safety and security, which are all about prevention, stopping bad things from happening, whether they're accidents or deliberate attacks. But then you have explainability, and that's about something deeper. It's about transparency. It's the audit trail that creates accountability and lets us humans build real, genuine confidence in our AI partner.
And honestly, this concept of explainability, it might be the most crucial part of this entire discussion. You can think of it like an unbreakable, auditable receipt for every single thing the AI does. Every line of code it writes can be traced directly back to the human request that created it. This isn't just a nice feature, it's an absolute requirement for debugging, for security, and for building any kind of real trust in the system.
All right, and that solid foundation of trust is what lets us look to the future. So how does a totally new language like this actually fit into the world we live in now? Well, the goal isn't to burn everything down and start over. It's about connecting to the tools we already use to unlock the ideas of tomorrow. Look, for any new technology to actually succeed, it has to play well with others. And this language is designed to be the ultimate team player. It's built to connect to existing APIs, to use powerful code libraries from languages like Python or Java, and to deploy easily to the cloud. The point isn't to throw out decades of incredible work, it's to build a powerful new interface on top of it all. It doesn't replace the tech world, it makes it accessible to a whole lot more people.
So, what's the end result of all this? What's the big payoff? Well, you create this amazing virtuous cycle. Because development gets way faster, more people can try out more ideas. Because the AI helps make sure the code is high quality and safe, those ideas are more solid and reliable from the start. And all of that fuels a brand new kind of partnership, a genuine collaboration between a person with a vision and an AI that can help them build it.
And that brings us to our final question. If you no longer need to be an expert in obscure syntax, if all you need to be an expert in is your own idea, who gets to be a creator then? When code truly becomes a conversation, the number of people who can build and invent and solve problems, well, it just explodes. And that, right there, might be the most exciting part of this entire story.